Good afternoon everyone and welcome to ZeroDayLive. I'm Stuart Peck and welcome to the session today where we're talking about security training for developers. We have a jam-packed hour and a half today, but if you do want to ask any questions, we've got people on the channel today that are going to take note of those questions so we can go through them at the end. So for you who don't know me, I am Stuart Peck. I'm the Director of Cybersecurity Strategy. I head up education and training. I also get involved in GRC, and I've done lots of talks with Peter on secure coding, and I've been here for about 7 years. So, Peter, did you just want to give a brief introduction to yourself?
Hi, my name is Peter Ganzevles. I am an IT security specialist at ZeroDayLive at the moment. However, I started off as a developer, like a lot of the people in the stream will probably be. I have a few years of coding experience and slowly moved into secure coding from there, and from there into a more offensive role as a pen tester with focus on mobile, web applications and infrastructure. However, I still do a lot of secure code review and trainings on security. Excellent.
Well, we have, as I said, a jam-packed session today. We're going to discuss these three kind of topics and the kind of strategy for the outline today. So the first area we're going to talk about is understand, and that's really about how to understand sort of how vulnerabilities are exploited. And the next part is
how to learn from these mistakes and how to learn from vulnerabilities in general and what we can do to then
enhance, so act and enhance the security of the code and the kind of tactics and techniques to improve that moving forward in the development lifecycle. So we've got three areas we're going to talk about of how to essentially improve security within the kind of development lifecycle. So before this, we're going to talk about understanding the threat landscape, and we've kind of done a little bit of research and sort of drawn down from our experience in obviously testing applications and doing threat modeling and all this kind of stuff. And really, we want to kind of highlight a few things that we want to sort of bring out today in terms of topics that kind of support our discussions. But the first thing is that about sort of 6 months ago, I kind of came across this kind of summary of the cost of a vulnerability within a web application. And if you look at the kind of figures like 400 to 4,000, depending on the complexity, to kind of cost of fixing or remediating that kind of vulnerability. And you know, when we start talking about pen tests and ethical hacks, you know, we will find lots of those, you know, lots of vulnerabilities in a web application. I know that you have some experience in this as well, Peter, right?
Yes. So 5 to 10 is definitely in line with what we currently find in pen tests. However, we have definitely found up to 60 vulnerabilities or occasionally even higher in a single application. So with some quick math, that shows that you're up to 2.5 million down on a single pen test, which most of it, as we will discuss, can be prevented by having good code quality to begin with.
Yeah, absolutely. And of course, when we're talking about this cost, we're talking at the vulnerabilities that are discovered during production. So they've already been released into the production environment. So the cost is always going to be significantly higher. However, if you then identify these things earlier in that development life cycle, whilst you're still building, the cost to fix those are obviously going to be dramatically lower. And this is what we're going to talk about today.
Yeah, and keep in mind that these are estimates of cost, but they are estimated on about 40 man-hours to understand and fix the vulnerability, which, as we'll see, might not even be accurate at the moment.
Absolutely. Well, if we talk about that we'll go back to that because that's just gone there. There we go. Right. So, if we look at the issue here, that the tax rose 800% on 2020, which is a significant amount, right, in terms of number of attacks against web applications.
Yeah, it's incredible. It's partially due to the working from home situation as well, of course, where it becomes easier to find time to do these things. There's also an ever-growing amount of attackers present that will be attacking your web application, so that is also part of the rise. But we definitely assume that for the second half of 2020 that number will even go up even further.
Yeah, and we don't know what the figures are, but we think it's going to be a dramatic increase on last year, even.
Oh yes, definitely. Probably hitting the 4 figures at this point.
And already that figure we talked about from 6 months on the previous kind of slide of being like a number of days to fix. We're already looking at the average time to remediate last year and beginning of this year. It's like 50 days. So that cost has already gone up. Right?
Yeah, it's already a 25% increase from the statistic we saw there. So we can assume that would also reflect in the cost, and that quickly pushes up the numbers.
And one thing that I looked at recently is the kind of, the bug bounties, because that's a good yardstick for what people are finding across organisations within web applications in particular. And the highest earning bug bounty for last year was cross-site scripting, paying out over 4.3 million in total to bug bounty hunters. And that kind of surprised me because it's a very common vulnerability, but surprised that it was the highest.
Yeah, so this can be explained by a few factors. First of all, XSS is one of the easier to find issues. It's something that a lot of people will have heard about, relatively speaking, and as such there will be more people hunting for it. However, this also means that generally they will be fixed quicker, or at least found quicker, and therefore the fixing process will start quicker. And keep in mind that a lot of XSS actually have a relatively low impact compared to some of the other vulnerabilities out there. So since bug bounties often pay relative to the impact of the vulnerability, these vulnerabilities are numerous.
Well, to get 4.3 million, there must be a lot of XSS vulnerabilities, right?
There are a lot of XSS, yes.
Yeah. Okay, so what we're looking at now is moving into understand vulnerabilities. We always mentioned one vulnerability already, but what we're going to talk about now is a greater level of understanding of why applications are targeted. And of course, there are numerous reasons. And the first one, of course, is potential for attackers to gain access to large amounts of customer data.
Yes, customer data is definitely still the key target. It is vitally important for things like targeted ad campaigns, but equally so for things like phishing campaigns or identity theft to gain large amounts of data. So a lot of PII is sold in on the black market, for example. However, it's also, of course, things like credit card information, bank account details, personal information that is not necessarily identifiable, but is used for large metric identification.
Yeah, and also, like I said, identity theft, or the value of data is pretty high, depending on the quality and volume of data, right? So it's like the new oil; it's a commodity, right? But it's incredibly valuable.
Yes.
And of course, one of my favourite topics can be used to like supply chain attacks. So obviously we've got updates of malicious code that can cause, from a major vendor or supplier, that can actually cause significant damage to lots of different organisations, right? And of course, we've got two recent examples. Obviously, SolarWinds being the most recent, obviously causing massive amounts of damage, and NotPetya, of course, a ransomware attack that was delivered through MEDocs, which is again a software update that had a massive impact globally to organisations. These are really good examples of where supply chain and also insecurities in coding can be abused, right?
Yeah, and as you can see in especially the NotPetya example, it is a long-taking process to remediate it, isn't it?
Yeah, it took a long time to remediate against that particular attack, and was cited to be, I think, is one of the most expensive, although SolarWinds may overtake that, of course, cyber attacks in terms of cost to businesses over like $1 billion, which is significant, right? Yeah,
and speaking of damage, it's not just financial damage. There's also a lot of brand damage when a server goes down or a site gets hacked or leaks information. Your website is still your calling card, your business card, isn't it?
Yeah, absolutely, and it's and of course that has an implication if that goes down, either that's through a malicious attack or some kind of availability issue. Still, the first thing people will do is say, oh, it's a cyber attack. And a good example of that would be yesterday when a lot of web services went down through the content delivery network, Fastly. the first thing that people were automatically assuming, this must be a cyber attack, and it actually wasn't in the end. But the point is, that's the first thing people assume. So again, we're in this kind of mindset that everyone thinks everything's a cyber attack, but of course, if a website goes down, it possibly might be.
Yes.
And of course, one of the areas that we do talk about quite a lot and really gets overlooked is that kind of ability to pivot into other assets, right? From the front end of a web application. Did you want to talk a bit about that?
Yeah. So regardless of where an application is hosted, it is generally not the only thing that's in the vicinity, as we would describe it. So if an application, for example, is hosted on your internal network, or say in your DMZ, it is fairly simple once you gain full access to the server to start pivoting from there into the rest of the network and potentially get into the internal company network to cause some major damage. Alternatively, if it's hosted in something like Azure Cloud or AWS, it is likely that you'll find AWS keys or Azure keys or secrets, and use those to go to other domains hosted by this company to get more information.
Absolutely, and it's something we're going to talk about later about sort of microarchitecture, Docker and things like this, and cloud hosted environments, and where the risk could be in terms of pivoting into those environments as well. And of course, an area that gets very much overlooked is human error, right? So when we talk about web applications or mobile applications or development, there's always that human error involved, whether that's coding issues or whether that's the social engineering aspect. I mean, the first one, of course, is we actually have lots of conversations about this. It's about the amount that we see companies sharing too much information about the inner workings of their applications.
Yeah, or for example, to release, once again, credentials, keys, accidentally pushing them to, say, GitLab or GitHub, and having those world readable to everyone. Alternatively, as you said, unreviewed code or unpatched code being pushed out. There's a lot of human errors that are not necessarily a lot of work to fix, but just small things that can have massive impact.
This comes down to process, right? And this comes down to having things documented and having controls in place to prevent these things from happening. But in some cases, that isn't always in place.
Yeah, and security awareness. That's not to be understated as well. Security awareness is key here, and that's what we'll be discussing in a minute, I assume.
Yes, absolutely. And one thing I will talk about as well is the kind of hard-coded kind of keys and information in GitHub repos and things like this. They are quite easy to find, and I've got a couple of examples here because I like open source intelligence, and so I did some digging around and found just a couple with a couple of quick searches. And one of them is obviously a private RSA key that someone had removed but forgot to remove from their repo, which is actually quite important. And there's actually quite a few other things that they forgot to remove as well. And then, of course, here another example of someone who's removed a private API key, but not fully removed it. So we've got like about 4 or 5 different API keys there that we could use as an attacker, which is incredibly valuable. And of course, something which we see very, very frequently. And there are tools out there, again, that you can use to kind of scan your GitHub repos, like GitRob and things like this, to find secrets, and you can do the same with AWS as well. But ultimately, this are still things which we still see on a regular basis. It's things to think about, because if I get hold of these keys, I can do quite a lot. And of course, it allows me potentially to get into your environment, and of course, from there, move wherever I want to, potentially, within that environment. So I think, talking about web applications, it's probably a really good place to start to talk about the OWASP Top 10.
Yeah, the OWASP Top 10, or the Open Web Application Security Project, is a group of security specialists who every few years will publish a new Top 10. And the Top 10 being a list of 10 categories with the most impactful vulnerabilities and most common vulnerabilities over the last few years. And it's ever moving. There's always changes. You'll see things like injection always being near the top, because injections doesn't seem to go away. But there are a few interesting entries here, aren't there?
Yeah, so we're talking about highlighting sensitive data exposure and insufficient logging and monitoring. And I guess just to bring back your point before we move on to that in terms of injection, I think SQL injection is 22 years old now?
Yeah, just about.
Yeah, so there's a vulnerability right at the top that's 22 years old, and yet we're still having issues with injection across the board. So we know that this is a very common and very serious vulnerability, but we still seems to be very common and very vulnerable. So there's a big issue here that we need to talk about. But
yeah, and keep in mind also that injection is not just SQL injection. There are many more, and a lot of them are equally as old.
Yeah. So and so sensitive data exposure though is a fairly recent one. Right? It was added fairly recently, and of course insufficient logging and monitoring is a really important topic we're going to discuss as well, and because these are sometimes overlooked, but can be quite impactful when you realise the consequences of it. And the first one, of course, if we talk about sensitive data exposure, this kind of takes us back to the conversation we had on our last seminar, which is about the importance of understanding your assets and understanding what's contained within your assets. And from the topic of web applications, it's the data that's contained within those assets, all the information that you are publicly sharing within those assets that could lead to a lot of risk. So we talked about keys and private keys and secrets and things like this, but actually the data that you are processing and why you're processing that data and how you're storing that data is so important.
Yeah, absolutely, and it's the storing of the data, as you mentioned, but it's also why you're storing it and how much of it you really need to store. Is it worth keeping all this data? Is it worth storing it within your application, or can you rely on the user providing this whenever it's needed?
And some examples, obviously, no certificate checking or enforcement, data's transmitted in clear text, and you've got some examples of this as well, right?
Yeah, absolutely. We still find large amounts of data being sent over clear text, simply not using HTTPS as it's commonly referred to, simply having login happen over clear text so that anyone on the network can read the credentials, can read the information needed to log in. But of course, there's also the occasional database that gets backed up, and the backup never gets removed from, say, the web root or something along those lines, where it can simply be browsed to and read by any third party.
Which obviously, if that data is also not encrypted, is also a major issue as well, right?
Yeah, that tends to go hand in hand, because people that don't encrypt the database also tend to not encrypt the data within the database. So
yeah. And of course, there's some things you can do to kind of protect yourself against this. So obviously, the first important part is to understand what data you have, whether you should be processing it in the first place, and actually where that data should be stored and how it should be stored. Ultimately, should it be encrypted? The answer is yes. And should you be processing that much data? The answer is, well, that depends on the purpose of your trying to process it. But ultimately, making sure that it is stored in appropriate way in line with the regulation or laws that you're supposed to do it, but ultimately, is it in line with best practice? Yeah,
and of course, there's the one classic exception to what should you encrypt. Don't encrypt the passwords. Keep that to hashing and salting, much more important. The problem with encryption is that generally the encryption key will be on the server as well, so it is possible to reverse the encryption and get the plaintext data out of it. That's part of the function of the application, of course. But it is important to note that hashing is a one-way algorithm, meaning that if the password is correctly hashed and salted with a strong hash, emphasis on strong hash, it is not likely that the password can be recovered by an attacker.
Yeah, and of course we see lots of people using weak hashing algorithms like MD5 and things like this, right?
Yes. It doesn't really make a difference whether something is stored in MD5 or plain text nowadays. It's not that difficult to reverse.
So I think it's really important to say that this is obviously quite an important topic. But then, of course, we've got the other topic, which is insufficient logging and monitoring. And of course, we highlighted this because this is actually quite vital to most applications when people aren't storing the right kind of logs or separating the logs out or even logging those applications. Because if you don't detect something happening in the first place, it gives the attacker a lot of time and potentially latitude to do what they want, right? Completely undetected. So what sort of advice would you give around this sort of topic?
Well, first of all, logging is important for more ways than you might think. It's not just to detect attacks happening, but also to detect failures happening. Detect which of your assets are more of a target than others. And afterwards, they also help with figuring out what attackers might have gotten access to.
Which is vitally important, right?
Yeah, absolutely. Additionally, it is key to have logging to detect persistence, because the key part for an attacker usually is not getting to your server, because once they get to it, they need to actually do something with it, and that tends to take time. What an attacker really wants is persistence, to stay on the server and be undetected for a long time, which leads into the point that logging should also not be done just on your own server. It should be done in multiple places, on multiple physical locations. For the main reason that if an attacker manages to get to your server, the first thing they tend to do is wipe the local logs, things like the Windows event log or anything written locally by Gabbana, or any of the log applications that might be reading data sent to the server.
Like Logstash, things like this, right? All those kind of things, right? Gabbana, as you mentioned, Logstash, sending stuff to like Datadog, or your SIEM, hopefully, and your SOC if you've got one. But those kind of things are really important, and actually monitoring applications and separating out the security logs from the troubleshooting logs, or the other different types of event logs, like the different logs you might have in the application to help support when an application's got some errors, is actually quite important to separate those out, so you've got different routes for different types of things. And also, to add to that as well, making sure someone actually reviews those logs, right? That's pretty important. So having alerts going off anywhere and no one actually looks at them is just as bad as not having any logs. Yes,
or having someone look at them and not understanding what's happening. It needs to be a person knowledgeable of the application that they are reviewing the logs for, and able to act on this and not just see.
Yeah, absolutely. So I think the next topic, again, is like talking about the ensuring that you've got those kind of audit trail, and making sure that the logs that you do have as well can't be tampered, right? Because that's quite important. Tampering of logs and deletion of logs and preventing that is obviously quite important as well.
Yeah, as I mentioned, it's generally the first step for an attacker to hide their traces or hide their tracks as well as possible.
Absolutely. Okay. So we've also got the OWASP Top 10 mobile as well.
Yeah, so despite the WA in OWASP standing for web application, they do have a mobile top 10 as well now. While this topic is not really suited for this specific event, there is an interesting point to mention here, and that is number 7, client code quality. So this is the first time that code quality, or more specifically the lack thereof, is actually considered a vulnerability, isn't it?
Yeah, and this is because the way that mobile applications are compiled, and we talked about this a little bit earlier, is about the fact that with a web application, the code is compiled by the web application itself, whereas actually on a mobile device you have the APK files and things like this, which could potentially be accessed, which you can actually then see the code itself if you have reverse engineering, all this kind of stuff. So it really becomes quite interesting that the fact that if your code isn't sufficiently good quality in place, it can be abused by attackers, like any type of code, I guess, but also the fact that you have more direct access to that code, so it becomes more important to make sure you've got the controls in place around it.
Absolutely, and code tampering or even reverse engineering is not as difficult as it might sound to a lot of people. Mm-hmm. With Java applications on Android, for example, there are out-of-the-box tools that can reverse most unprotected applications. So it's not only important to have the security measures in place to stop the reverse engineering, but also realize that it's not possible to guarantee that it will never be reverse engineered, and thus it is important to have a good code base, and a code base that solves your security issues without giving away too much information.
such as secrets within the code, API keys within the code, all this kind of stuff that you may see, comments that give away too much information. There's a whole ton of stuff that you can see in mobile applications. Other services it might be connecting to, all that kind of stuff, right?
Absolutely, yes. And one of the most common issues we see there is still that mobile applications still most of the time get compiled with code comments. They should always be removed beforehand because they give away way too much information.
Yeah, absolutely. And again, you know, onto the kind of topic of expanding out the attack surface, of course we have things like microarchitecture, we have, you know, infrastructure as code, you know, the attack surface, external hosting and all this kind of stuff. And the attack surface is, from a development point of view, is massively increased because we think about Docker and how developers are now working within Docker and compiling applications and building out Docker environments where their code might be hosted in different places, or using Kubernetes and things like this. Suddenly, you know, developers are moving into much more DevOps as opposed to purely development. And of course, there are inherent risks in doing that.
Yeah, having developers work on multiple layers of the web stack, basically on the underlying frameworks as well as the application code, means that they have access to more, which means they become a bigger target, which we'll talk about a bit more later. But additionally, the fact that everything is now based on multiple layers of code means that there are multiple layers of code that can be insecure. And while you cannot rewrite the code for Docker, you can try to configure it as best you can and try and solve all your other security needs in your own code that is running on top of Docker.
Yeah, so it becomes very much more an architecture issue as well as a secure coding issue as well, right?
Yeah, since architecture is now also code, it's still a secure coding issue, it just is spread over multiple layers.
And it's a scripting issue as well, right?
Yeah, absolutely, because most things these days get pushed via scripts to external containers or to online services, etc. And even those scripts can be tampered with.
Programming is a big issue as well, right? So I think we're moving into this kind of area where that we're talking about now that the attack surface is massively increased, which kind of takes us nicely onto our kind of next topic about, you know, why we need to understand that, because now we're not just dealing with insecure code, we're dealing with other dimensions that support that as well. And threat modeling is quite a nice exercise to try and start to understand these things. And when we talk about that, we're talking about multiple things, really. We're talking about understanding, you know, your attackers and understanding who might want to attack you and why they might want to attack you. And this is dependent on what you're processing and the attack surface that you have. And of course, understanding that attack surface also determines what attack vectors you might be exposed to. So these are three very crucial things that should be done at the beginning of a development lifecycle, because it also helps inform where security might want to be applied or the controls you might need to apply. Especially if you're working in a very much more agile environment, then you would be thinking about security non-functional requirements and things that need to be checked off as part of the backlog. And of course, we need then talking about how we build that kind of security mindset into that development lifecycle. So these are things which we're going to touch on now, because I think it's an important topic that kind of refers to the rest of the discussion today. So one of those areas is we're talking about you know your adversary. So there are certain areas that you can look at to try and understand, okay, well, where would someone interact with our application? What level of skill would they have? And of course, what impact could that cause us? And there are certain ways of doing this. So one is to understand, okay, well, if an opportunist attacker was to target us, for example, what would they find? So the scenario of the exposed keys in our GitHub repo, if someone found those, what would they actually do? What would they actually be able to do with it? How, you know, obviously we're worried about that, so we shouldn't be there in the first place. But if someone found some information, or we weren't tokenizing personally identifiable information or secrets or things like this, that might cause a big issue. It could also be someone who's doing responsible disclosure and has found a major issue. That's obviously a good thing, but ultimately, if you don't have the relevant disclosure process in place, that could cause an issue as well. Also, like your motivated attackers, right? So someone suddenly much more technically capable might have some resources, might have a hidden agenda or very formal agenda in terms of stealing data and selling that data, or whatever it may be. obviously there's your attack surface is now massively increased because they're going to be targeting much more of your application potentially to try and get to that. And of course, the advanced attackers could be, we're talking about someone who's going to spend a lot of time, a lot of resources, because the payoff is big enough. So therefore, you then have to then map in a lot more of your attack surface to understand where someone would target and what they would, and the persistence they may want to gain as part of that.
Yeah, as you mentioned, the persistence, as you go down on this list, the persistence increases per category, basically. And while opportunistic attackers can more easily be deterred by having a secure look and feel to your application, a lot of the more advanced attackers will simply look past it and truly dig deep into the application until they find what they need, if at all possible.
Yeah.
So it's very much getting it right at the core level is the only real protection against that.
Absolutely, and it just takes us into the kind of the important part of this. For me, the kind of crucial part, because this is the bit when if you understand this element in terms of what is that attack surface look like, so what is the application made of, what are the components, where can someone interact with our application, what forms, fields, databases would they might potentially go after, and of course more than that as well. It's trying to understand what does that application look like architecturally, what does it look like from a functionality point of view, what integrations do we have, all this kind of stuff. What's the ecosystem that makes up this particular service? Because understanding that will cause a lot of decisions that could be made around improving security.
Yeah, and even at the low level of simply what technologies are you using, what methods are you using, what languages are you using can be a major asset to mapping out your attack surface. And
one thing we haven't actually talked about yet, which is really quite important, is third-party libraries, right? So massive attack vector. If you think about groups like MageCart in the past and still going on, but not as much in the news. The ability to target weaknesses in third-party components and libraries, that you may have checked your own code, but if you checked your third-party libraries, what if they have components that have weaknesses that can be abused? What if those components also have weaknesses as well? Because ultimately, every library may have a third-party library that's not supported anymore, may have inherent weaknesses. And how far down that chain do you actually go? Yeah,
and also vice versa. What if you are part of a chain the other direction? What if you are a component of something else? And it doesn't have to be a library of some kind. It could be that you are feeding data to something else, and the data could get corrupted due to a vulnerability in your website. Someone might be able to inject SQL into your database, modifying the data sent to another party, and inherently you are then also responsible for not sending malformed data and for making sure that the data you send to the other party is secure.
Yeah, so you can go quite far down the rabbit hole either way, really, can't you?
Yeah.
And it becomes a real issue. So understanding this, and it goes back to assets in some respects, understanding the ecosystem and the integrations, and also where you are part of that ecosystem is quite important as well.
Yeah.
Because that determines where you can start to apply the next stage of this, which of course is understanding the threat models through methodology like Stride or whatever it may be, to kind of understand where the vulnerabilities can be applied or where the attacks may come from, right? And we've got obviously spoofing, tampering, repudiation, information disclosure, denial of service, evasion of privilege. These are things we need to look at, right? There are a number of attack surfaces you can start to build in once you understand the applications you're working with, or if it's just a function you're working with, right? Where does that function also increase the attack surface to the application you're trying to develop something for, right? So if we look at spoofing, for example, we can start to look at some of the attacks that might be involved in that, and we're trying to build out where we might want to increase our security in that application. I know there is one particular topic that you're quite keen on.
Yeah, we're a big advocate for the fourth topic on this list, actually, CSRF, or cross-site request forgery. And the main reason why we put so much focus on this is because it is actually a very serious vulnerability, and it's a vulnerability that can be used as a delivery method in order to gain further access into the application by delivering payloads on behalf of someone else. So you can potentially deliver malicious payloads with admin privileges. And the reason why we're so keen on this is because it used to be a top 10 issue. It used to be number 8 in the top 10. And over the years it has dropped down off the list, and not because it was no longer necessary, but more because other things came up that people paid more attention to. And we saw that basically from the moment that it dropped off the list, any application that was created afterwards that didn't already have it wasn't paying as much attention to CSRF as the ones previously. So now we see that this vulnerability, this application vulnerability, is once again climbing up the ranks to be one of the more widespread issues. And I would definitely not be surprised to see this higher up on the list in the next version.
We were talking about this, weren't we? We're saying that, you know, I wouldn't bet my house on it, but I'd put a strong bet to say that we may see this up again in the top 10. I mean, I'll be surprised. I mean, I may not be, but...
yeah, and even if it doesn't make the top 10, it'll definitely make top 15.
Yeah, 100%, yeah.
100%, yeah.
And of course, if you look at, you know, like tampering, obviously tampering are very serious attacks, right? And we talked about, you know, injection, you know, and abuse of insecure third parties and XSS. You know, these are attacks that can have significant impact, especially the ejection side, when you're able to dump information or inject, you know, like I said, malformed data or whatever it may be. It's pretty significant, right? And you know, so these are things we need to be thinking about, and actually what controls we apply at that development life cycle and how we identify these things earlier. And again, we've already talked about third-party libraries, so we won't talk about that now. But of course, repudiation, a word I actually really struggled to pronounce, and I thought I got it, but not quite. But we'll let you say it. Go on.
Repudiation.
I did say it right then.
Yeah,
okay.
you did.
I almost got there. It's on the run through, it was perfect, but there you go. But the whole point is, it's about a kind of understanding how to make an attack non-attributable, right? So we're talking about you know, how I can mask my attack, or how I can attribute this to someone else potentially. And of course, you know, one thing I always talk about is deleting or overwriting of logs, or you know, making sure that you're not visible in logs. Is quite important, but there are other ones as well that you've got some thoughts on. Yeah,
XML is a technology that we see being used more. It's an efficient data transfer method. It's also used in data storage, for example, in NoSQL databases. And XML external entity injection has been part of the vulnerability lifecycle, so to speak, for ages. And the fact that more XML is being used means that this is more likely to happen, especially since a lot of the XML parsers are struggling behind on their default security settings.
So it's causing major issues.
Yeah, and this can go as far as gaining full access to a server in a matter of 4 lines of code.
Which is, I'd say, pretty significant, right?
Yes.
Yeah, pretty significant. And of course, you know, information disclosure, right? So, you know, we've already talked about, you know, information that's left exposed or accidentally exposed, which can be useful, not only just for conducting a direct attack, but also to learn how to conduct more attacks against an organization, or as a step attack. So if I get some information about the application, maybe there's error messages with too much information, which is always a quite popular one, right? So actually giving too much information with error messages, I can use that to learn more about the application, or force an error, which then can give me that information I need about the applications I can use to attack them further. Obviously, we've talked about you know, personal data in URLs and things like this, where if I'm not tokenizing that information, I can use that to potentially use it to gain information and still take over accounts, or even use it to gain information about script something to get information about the database itself.
Yeah, and here we also do see the flip side of logging. While we do want you to log significant amounts of information about what you're doing, we never want you to log any personal data or any passwords or anything along those lines, because logs can leak. It is always good to assume your log will eventually leak, and it's as such that you don't want to put anything in there that's identifiable as personal information.
100%, yeah, absolutely. Tokenize information, or use IDs or things like this potentially, but do not use personal information, usernames, things like this.
Absolutely.
And of course, if we talk about denial of service, because obviously denial of service is not distributed denial of service, that's slightly different, right? So there are areas that we're talking about here, so you've got some examples potentially.
Yeah, so as you already touched on, there's a significant difference between distributed denial of service, or DDoS, and denial of service, or simply DOS. And this is an important distinction because DDoS, or the distributed version, is theoretically non-preventable, because given enough information and given enough server capacity and given enough IP addresses, you can always deny the service a server, because every server has a limited capacity. And there was even a great white paper recently on how if you were to hire 2/3 of the Amazon cloud, you could deny the service the other 1/3 of the Amazon cloud, which is fairly pointless and very expensive, but nonetheless it's
theoretically possible.
It's
right?
theoretically possible.
Yeah.
Denial of service, on the other hand, is a single client shutting down the entire server. And once again, external entity injection, or more specifically external entity expansion, comes in play here, where attacking the XML parser running on your server might be enough to take down the entire server.
Which again causes a major issue, right? And but this is preventable from a coding perspective as opposed to buying an anti-DDoS tool, because it's solving a different problem altogether, right? And of course, elevation of privilege, which is pretty significant.
Yes, once an attacker manages to get access to higher privileged credentials, such as an admin account on the website, they can try to escalate those further and get potentially physical or virtual access to the underlying server. This server can then be compromised to, say, root or admin credentials. Once again,
yep.
Another privilege escalation. And once that is the case, you can freely propagate through the network with very little effort in most cases.
Yeah, absolutely, and there's some other ways as well. Improper privilege management, so it's the same everywhere really. Make sure that you have least privilege in place, right? And you protect your privileged accounts, because if they get compromised, that's a pretty big issue, right?
Yeah, and deny by default. Make sure that no function is allowed unless specifically acceptable. So, as you mentioned, least privilege, but also make sure to use whitelists rather than blacklists, and make sure that the user does not have access to information about his own account or their own account, and make sure that they don't have access to, say, a token that they can modify to up their privileges.
Yeah, absolutely. So JSON tokens, things like this.
Yes.
Use, yeah, which is very common. Okay, so it's really about bringing this all together. So we've understood our potential attackers that might want to target us. We've understood that we have some potential risks that we've exposed through understanding our environment and the environmental controls that may or may not be in place. And we've tried to model some threats. And now you want to be thinking about, from a development point of view, what does this look like, and where do we need to start thinking about the attacks that might expose us? Because ultimately, we want to look at the controls that we can implement. And this comes down to the process that we're going to talk about today, which is about the development controls and the training and the process around that. So we've understood some of the basics. Now we're moving on to the area of next, which is to learn, right? So we need to take in the theory, but understanding the fundamentals of how vulnerabilities are created, and to understand what vulnerabilities you might be exposed to, we need to learn now how to prevent them, right? This is the most important part, and how to discover them within our own code base, right?
Absolutely.
And so the first area we're going to talk about, which is our favourite topic of the day, is common misconceptions, because these are the things that we hit, me and you and all the people that work here actually hear quite a lot. Where should we start, I guess?
There's no good start in this one. The one we hear most often probably is we do not need to worry about vulnerability X because we are using tool Y, and specifically things like we don't need to worry about XSS, we use a secure language, or we use more often even we use a web application firewall or WAF.
Yeah, and this is interesting because I've got an analogy for this, right? So, and there's obviously, you know, I'll sort of talk about that. So the idea of a WAF, in my opinion, is basically a WAF is a plaster for a cut that needs stitches, right? While you may need to plug something quite quickly, so you may identify that vulnerability, putting it, you know, making sure you have a WAF in place will stop, you know, potentially stop some of those attacks. But if someone is able to bypass that WAF, which is very possible because WAFs can be bypassed, and there are, for example, certain scripts you can run that potentially will allow you to bypass certain WAFs, and of course this is a continual kind of thing. If the underlying code is not being fixed, therefore the attack is still exploitable and therefore vulnerable. So there are certain circumstances as well where the fix isn't easy, and therefore a WAF would make a lot more sense as well, because ultimately it might be an incredibly complex and a long thing to fix that may be systemic across your entire environment. So there are obviously values for doing that, but of course the most important thing is you have to get the stitches, you have to fix the code, because ultimately a WAF won't fully protect you, but you should still have one.
Yes, absolutely. It's a first measure, but it's only defense in depth. It's only as good as buying you time. It's not going to fix the issue. It buys you time that might give you enough time to fix the issue before it gets fully exploited.
Absolutely, yeah. We talked about patching as well.
Yeah, patching is often misunderstood. It seems very simple. We have a tool, there is a patch, we apply the patch, we're done. But it's not that simple, is it?
No, because sometimes, and we talked about this earlier as well, is that sometimes patches can, another analogy, we'll use another one now, is you might close one door, fixing an issue, and open two more. Right? Or you may have unnecessary features, which we talked about as well, which could mean that you're increasing your attack surface.
Yeah, absolutely. If a patch does not fix any issues that you currently have, and it doesn't add any features that you are actively using, there's a very high chance that you are simply introducing more unused code to your system that is still accessible and that might still be vulnerable, and if used at a later date, could be exploited.
Yeah, and so, you know, there are examples even today of exposed, slightly off topic but slightly on topic, of, you know, the Hafenum issue that was a couple of months ago that was sort of talked about by Microsoft. There are still exposed Exchange servers to the internet today that still haven't patched. So, you know, patching is obviously about prioritization, right? So obviously you need to patch stuff if it's critical, but you may have two services that you say, well, actually we've got two applications, we can't apply the code to both these applications because one might take a bit longer, or you may be like a pen test report, for example, where you've got a critical vulnerability, but it's not on a critical system. So you still need to fix it, but I've got a medium or high risk that's on a critical system. It's about prioritization. I might focus on the high risk because ultimately it's a pretty serious vulnerability. It's not critical, but it could cause a major impact to my organization.
Yeah, and this prioritization takes a lot of time and a lot of trial and error, but it's definitely something to focus on when creating your own secure environment.
Absolutely. Logging. We talked about the importance of logging earlier, but why is it a misconception?
There are two camps in this really, or two statements that we hear that I wouldn't say trigger us, but at least put us on edge. And that is the one half that says that they don't need to log because their code is secure. Well, how can you prove that your code is secure if you're not logging and if you don't log potential attacks? Mm-hmm. Because if you don't log any potential attacks, even though you might be entirely convinced your code is secure, if you don't log potential attacks, you can never prove that there weren't any. Mm-hmm. On the flip side, there are the people that will tell us that they don't need to log because, or sorry, that they do everything with logging, and that they are perfectly capable of at any given time telling us exactly what's happening on their server, and thus they're not too worried about fixing their code. Which
it's the either-or situation, isn't it?
Yes.
And I think to your point about the secure code, although it's really important, is what we're talking about today. You can never really actually validate whether your code is secure unless you're logging, because you may be like, okay, we've got all these attacks against this particular piece of, this environment, but we're then able to then prove it was successful. They weren't successful, so therefore we have more confidence in our code, right? So it's actually quite important, right? And I think it's pretty good. And I think we talked about tools and substitution. There's no substitution for proper coding. In fact, it's about having the right frameworks. It's about having the right methodology for coding. It's about having the right processes, the environmental controls, and then the technical controls. And it's a process, right? It's not just one thing. It's the harmonizing all those things into one basic pipeline, right?
Yeah.
So the next point is development controls, right? And we're going to talk about what we call the developer security improvement lifecycle.
Yeah, so we have realized over the course of giving many trainings between mostly you and me that we have that is a more general approach to setting up an almost cycle, a process to learn more about security and to increase the average security level within the company. And this is very much based on the cycle you see in front of you. So the first thing you need to do at any given point, and this might sound very obvious, but it's something to keep in mind nonetheless, is to realize that your code might not be secure, and to accept that your code might not be secure, and to be willing to do something about it. And once you have the code quality, you can start working with it, can't you?
Yeah, absolutely. And to understand how your code is secure or not secure, I guess, insecure, is things like pen test reports might give you a good example. So you might see a understanding that we're seeing the same vulnerabilities being created time and time again, for example, across different systems. That might be not necessarily insecure, it might be a process thing, right? It might be the fact there's a knowledge gap, right? So there are different mechanisms and different areas to look at to understand the level of quality in your code. Automated tools won't always give you a full understanding of the quality of code, but it will give you some understanding. You know, some of the SAST and DAST and things like this may give you a high-level understanding of the issues, but it won't give you the complete picture. The other area to look at, and this is where we're going to talk about now, is the awareness, the security awareness. We talked about this a little bit earlier, but we're going to talk about it now, of the developers. So I did a talk at OWASP a while ago when we were allowed to do presentations in front of other people, when I asked a question for a bunch of developers in the room, about 200 in the room or something. I asked them to say who was developers in the room. They all put their hands up, and then I asked them to keep their hands up if they'd had anyone given them any security awareness training specifically for what they do.
How many?
One or two people kept their hands up,
Yeah.
right? And it was quite a shock to me because I thought, well, why wouldn't you make sure that your developers are getting awareness training around the latest threats they may be exposed to, because they are a prime target for people like social engineers or attackers, because if you compromise a developer account, it's pretty much keys to not just the kingdom but to the environments that support that. I can then potentially push malicious updates out. If there's no good segregation of environments or processes, there's lots of things I can do. I can gain access to the GitHub environment, I can push out commits and things like this. So it could be a huge goldmine that people are missing here. So making sure that the security of the developer's personal security and their overall maturity and understanding of where they might be targeted is looked at is actually quite important.
Yeah, and as someone who does a lot of work on social engineering, you clearly see a lot of developers come by who simply do not have what we consider to be a sufficient level of security awareness.
Yeah, I think they have a good baseline, but I think it's about understanding that they are much more of a target than they realise. And it's also about the organisation's understanding they might be much more of a target than they realise, doing like targeted phishing campaigns against them and things like this. So there's a whole bunch of things that that you might want to think about when thinking about security developers. But also, we need to talk about the next bit, which is the code training, stuff like this.
Yeah, so when you realize that code might be vulnerable, and when you have accepted that there's something that might need to be fixed, or when you realize there might be something that needs to be fixed, and you are aware that your security devs are potentially the biggest target, and keep that in mind, you can then start looking at a secure coding training. And this is not just for developers, as we'll talk about in a bit, no doubt, but this is also for the entire supporting staff. And Secure coding trainings are there specifically to increase your level of knowledge about writing secure code, because unfortunately, secure coding is not like riding a bike. It's not a you learn it once and you'll know it for the rest of your life. It's very much a you'll learn it once and you know at this point in time what the most secure methods are. But unfortunately, technologies advance, languages change, feature sets get expanded. So updating yourself on what is needed and what is part of the solution is key.
And it's not just relying on the frameworks, although the frameworks have got better in reducing the number of attacks that are possible against them. So, removing some of the common issues, you can still introduce components that are vulnerable that could potentially cause a risk as well, right? So
yeah, and even there's even certain cases where frameworks introducing introducing solutions to vulnerabilities, or even introducing something along the lines of a baseline fix for a vulnerability, as they call it, introduces more vulnerabilities in and of itself.
Yeah, so again, understanding the core principles of secure coding is much more than saying we use a secure framework, right?
Yeah. So where do we go from there?
Well, ongoing assessments, right? So we're talking about skills assessments, we're talking about ongoing testing, code review, building this into the pipeline, creating a secure SDLC process as well, so making sure security is involved in the process, whether you're in agile, or if you're still in waterfall, or whatever you're trying to do. Having that security kind of checks in that process is quite important, and then kind of going back to checking pen test reports. Are we seeing an improvement in code over time in pen test reports? What's our secure code scanning telling us? What's our DAS telling us? Our dynamic application security testing telling us as well? What is it? Or what metrics do we have to say that we have improved that? And if we don't, we can take it back to the well and start training and using that to improve. And of course, then we get to the point where we've got that baseline understanding of the principles. We can then start to model that to make sure we're checking it earlier in the process and then going back to the code quality again, right? So really it's about upskilling developers, right? This is the process that we're talking about. It's about how do we focus on upskilling our developers, and what are we focusing on here really? And really it's about, there's one area here that I think that me and you are really, really passionate about, and that is the kind of fostering security champions with the development team.
Yeah, security champions are definitely something we try to push for a lot. So what we often see is smaller groups joining our secure coding training or joining one of our other trainings and getting the information and then failing to spread that information throughout the company, or at least not spending enough time teaching the rest of the company to spread this awareness, spread this knowledge, and raise the overall level of the company.
Yeah, I think it's quite important to say that there's different methods for doing this as well. So one, you want to have a baseline of all your developers. You want to train all your developers to reach a certain baseline of kind of understanding, right? And then you want to focus on the kind of real kind of skill sets into your security champions who can maintain that knowledge, right, within the organisation. So, if you've got like 100 developers, you want to go, right, we want to make sure all of them are trained, we've assessed their levels of skills, we train those developers, and then we're going to focus on upskilling maybe 20 of those to be our champions or 10 of those to be our champions, so who can focus on really driving security improvement through that cycle, right? Absolutely.
And as we mentioned, while a secure framework doesn't solve everything, it's also a key part of keeping your average security level high, isn't it?
Yeah, absolutely. And having that kind of database of knowledge to know, so code examples or examples of where things have gone wrong, where you can show lessons learned, understanding, keeping up to date with the latest techniques, having a knowledge base that you can go back to and draw down on and actually really improve. And having it as part of your process as well, so you can identify these things. So rather than having people going off somewhere, if you're using Jira or you're using whatever it may be, having it all in one place where you can reference it is quite important.
Yeah, and you can even, in order to maintain this, we recommend creating things like challenges or capture flags, simply to maintain this knowledge and not just have a database somewhere, but actually almost force people to use it. And One interesting thing that we mention here is yellow team versus red team. Can you explain us a little bit about that one?
Well, it takes me on to our next slide, right, which talks about this, and thank you to a good friend of mine who provided me this image. There is a concept of the Infosec traditionally being your blue team, your purple team, and your red team, and actually, really, there's much more to that. The Infosec kind of, within an organisation is everyone's responsibility, but technically we've got the builders, the yellow team, right, the architects and the software developers, and they are part of the Infosec wheel. They are very much part of it because actually they are a crucial component if you're building applications. Security is a massive function to that, right? And really the process here is to say, well, how do we get developers to be more involved in information security, but also how do we get information security to be more involved with developers? They are part of the same ecosystem, they have the same objectives. One is about building something that's functional, but also that functionality has to be supported by security, and it has to be secure because otherwise it will cause massive disruption, right? So it's that kind of mindset change and that kind of understanding that security is a massive important part that doesn't have to be disruptive to a development lifecycle.
Yeah, and it's exactly this ecosystem where we really want to focus on, because the weakest link in the ecosystem is generally the one that breaks first, and that's why we focus on not just having the developers attend these trainings or improve their security, but it's about everyone, isn't it?
It is about everyone, absolutely. And I think the key thing here is about, when there is a pen test, it's about going through that with the developers, so developers understanding what the output was and where the issues were, so they can take that and then play test that in their own development environment and say, well, how can we improve this moving forward, or how can we change these things? And so it is really about improving that whole process. And it's also about including more than just developers in that training, right? And this is where things get really interesting, because we're not just talking about training developers, we're talking about people that support the development team. So, and people that might be involved in that ecosystem. So we're talking about the DevOps. DevSecOps is quite important. It's quite an important process. Or if you're really shifting left into that process, you can go SecDevOps, but I think DevSecOps will work for us today. The security team ultimately should be part of that training, because they should need to understand how the developers work, and so how best to support them. So they should be involved, and it should be not seen as security asking developers to do the training. It should be security involved with them, and we've seen that work really well in the past as well, right?
Absolutely, and even people like the Scrum Masters and the managers, while they might not understand the full technical scope of what each security vulnerability is, them being aware that they exist will allow them to properly quantify, agile stories for each of the topics, or even as simple as just checking whether something has been done.
In the backlog, is it in done, basically?
Yeah.
And also looking at the kind of testers, the QA testers, and the testers, having them involved is so important, because they're going to be reviewing the code and doing the quality. So can they not also look at the security of the code as well? So I think there's real big emphasis here on saying, yes, development function is the most, the primary function for the training, but actually really it's everyone else supports that as well, needs to be involved, because they're going to be involved in that process. So I think we're talking about really, as part of that, how best to learn, right? And what areas and how you can kind of teach developers and the types of learning methods available to doing that. And of course, we've got some examples here. So the first one being kind of topic-led.
Yeah, so topic-led is generally the way to learn about the things you didn't even realize existed. So, for example, if you didn't know that SQL injection existed, how can you ever protect against it? Whereas if you get a topic-led session with, say, a professional, or with an instructor of some kind who has prepared to work for you, they can teach you about these different topics, and they can teach you at least where to look and where to further research. And that whole research brings us into the second part, because after you have done the topic-led, after you have learned the areas that you are still missing knowledge, you have to learn about those topics that you now realize exist, don't you?
Yeah, absolutely. And of course, the topic-led stuff can also be driven through assessments and CBT programs and things like this. It doesn't always have to be instructor-led, because ultimately a CBT program can do the same as well. It's just about what's applicable to that organisation as well.
Of course, yeah.
And student-led, of course, is kind of driven through exploration, right? And it's much more interactive, if that makes sense.
Yeah, it's about asking the questions that you need to ask in order to get the information you need to further secure your application, to further act on whatever you need to do. And it also leads into the hands-on section.
Yeah, so we're talking about labs, practical, right? So, and of course, you know, if you're talking about development, of course, that's a very practical skill set to be able to apply the theory and the understanding into a practical exercise, such as challenges or CTFs or a lab that's been pre-prepared to actually test these things out. I think also cements the knowledge, right? Yeah,
so especially for things like security, simply sitting in a course for a week and listening to someone speak and death by PowerPoint is simply not applicable. You need to have hands-on practice with this.
Absolutely, I couldn't agree more. But what's really important here is about this maintaining of skills. So you've invested time and money and resource into applying knowledge transfer to developers, right? And you may have increased that through security champions and things like this. But it's really important to maintain those skills because ultimately, as you very rightly said earlier on in the session today, it's about the fact that it's not a one-off thing. It's a starting point. It's the start of the journey. Tactics change. You know, injection has been in the top 10 for a long time at number 1, right? But the tactics and the techniques for delivering injection against different frameworks, things like this, have changed. So it's knowing the application and being able to keep current is really important. But what are the ways that we can do that?
Well, as you mentioned the security champions. Those are definitely something you need to work on within an organization. However, that is focusing on a small group. You also want to maintain the level of the entire organization, ideally. And some of the best ways to learn are through things that are fun. Would you agree?
Oh yeah, couldn't agree more. Some of my favourites, capture the flag. I built a few myself and I really enjoy doing them. And I think having a good capture the flag competition, because people are quite competitive, is quite nice, but it doesn't have to be competitive. It could be collaborative. It could be whatever it may be. It could be testers versus developers, you know, whatever it may be. You could have a nice way of doing it, but what it really does is it applies the skills. In fact, didn't we do one for one of our clients a couple of years back? We created a CTF as well. That was pretty good.
Yeah, we did, and you see that it brings up other questions than, for example, reading a pentest report and verifying your pentest findings and whether those are still applicable. Or another way that people learn is things like simply ongoing talks within their group, so a weekly 5-minute chat about security, or research of their own.
Threat modelling exercises, workshops, things like this, enhance the general understanding. So there's different
Absolutely.
ways of maintaining skills. And I think the key thing here is having that plan. It's not saying you do the training, you build the baseline knowledge. It's about how you improve and maintain moving forward, which is really, really important. So this takes us into the final part of our presentation, which is obviously ACT. We've got to do something. We've got to reduce the impact. So we've talked about how we learn, and we've talked about how we understand. But now we need to know, well, what is it we can do to improve security moving forward? And of course, there are some ways of doing this. And of course, there is the understanding of the cost and time of improving security in the code over time. So did you want to explain this? Because it's obviously something you're quite passionate about.
Yeah. So this graph kind of mimics or gives a vague impression, at least, of the cost of fixing a vulnerability. So as you can see, in best case scenario, if you find a vulnerability in a code base, there is a cost attached to it. that's unavoidable. But in best case scenario, if the number of lines of code goes up, generally fixing the issue, or the cost of fixing the issue also goes up. And specifically, if the code is the vulnerable code is more scattered throughout your code base or applied in multiple places, it just takes longer to fix. If you, however, start to implement security from the start, the initial cost will be higher to learning to think about security, or at least have it in the back of your mind at all times. But you reach this point that we call security as a habit, where it is no longer a cost negative to think about security, because it's a habit. It's something that you just apply.
And I think the ability is the fact that there's an upfront investment of time to get to that point, but then over time it starts to go down because it's built in everywhere, and everyone is doing it. It becomes natural. It's the same as it is to write, a code to build a form, function. It's now security is baked into that, so it becomes, like I said, a habit, which is quite important, right? And of course, there's different approaches to doing these things as well. So, agile, you might want to think about how you can embed security into agile to reduce the number of fixes you might need to build, or later on down the line, how the time and effort involved in spent on security will reduce over time if you're doing it at the beginning of the process, right?
Absolutely, yeah, and building in frequent stories for security is a major part of building in security in Agile. Yeah,
absolutely. So there isn't like a one-size-fits-all, but ultimately thinking about how we do this and how we implement this all really falls down to the training, right? So if you don't have the knowledge at the beginning, it becomes quite hard to do these things later on down the line.
Yeah, it's all about picking it up early and frequently.
Absolutely. Okay, so I think we're getting to towards the end of the presentation, but really, the earlier you undertake training in that development life cycle or the product cycle, wherever it may be, and the quicker you do it as well, the better the overall benefits will be. But it's not just about doing it early, it's about doing it frequently as well, right?
Yeah, it doesn't need to be a lot of time. It just needs to be something you revisit at least once in a while, so that it stays in your mind.
Yeah, and again, it kind of leads that shorter curve. If you adapt, security adaptation is quite important, but that comes down through many factors. It's not just about training, it's about the champions, it's about objectives, it's about having the right process in place to make it easy to do as well, right?
Yes.
And of course, really it's about then upskilling developers over time. So it's also about saying we've created a baseline, and then we're looking at increasing maturity of the training over time and focusing on specific areas where we know that we've got potential risks of weaknesses in code being created. That's maybe down to a lack of understanding, but I think the way to get around that as well is also looking at doing skills assessments to understand, well, where is our biggest gap in security. So being able to take all our developers and say, yes, we understand that 70% of our developers have a really good level of understanding of reducing the impact of injection, for example, understanding how to identify what injection is in the code base and where the weaknesses are. But we may have a big risk around XXE, for example.
Yeah.
So, and that might be an area we want to hone in on.
Yeah, and it's all about raising that bar just a little bit every single time, but on a frequent basis.
Yeah, absolutely. And of course, how do we measure it, right? And how do we measure the effectiveness of training? I think we've talked about this quite a lot, actually, really. It's about sort of, that kind of, continuous integration, development pipeline, where the bug fixes are and measuring those, how many we've got over time. If we, of course, it's quite hard to say, will we have an increase in or reduction of bug fixes? You'd have an average that kind of goes up over time and down over time. Pen test reports, obviously quite important. DAST and SAST, so dynamic and static application security testing kind of results really help that. The important one really for me is that delta in time spent on security, really. Yeah,
simply the difference in time between how much time, or even if you're using Agile, how many story points are spent on fixing security now versus a year ago. How does it go down? And is the delta going down because you are spending less time on it, or is it because you are putting less emphasis on it, and are you just ignoring it? So keep that in mind, but generally a delta in the time spent, especially a downwards delta, of course, is good.
It's a positive thing, right? And unless the other delta is that the security weaknesses are going up, right? But
yes, unless the vulnerabilities are going up.
Vulnerabilities are going up, and there's a clear trajectory there you need to look at. But generally speaking, yes, it's good. Right, okay. And so, just to summarise, because I think really quite important here to say, we have spent a lot of time talking about the issues. We also have spent a lot of time developing courses for this. So, to understand, we do a lot of work around computer-based training and assessments to kind of baseline all of the developers to understand where the potential skills gaps may be and apply the training appropriately. Obviously, we have this 2-day secure code development course, which you can talk a little bit about, I'm sure. Yeah,
it's a course where we try to implement all these 3 points. Actually, it's understand where someone in front of a classroom will tend to go over the topics and teach you about topics you might not even have heard of, but also about learning about these topics, and then ultimately trying to apply these topics on the spot during an actual small kind of assessment almost on an intentionally vulnerable web app. So trying to break it and potentially trying to fix it.
Okay, good. Apologies for the noise back there. Right, okay. And just in summary, understand the threat landscape. Really important that you spend some time understanding where you might be exposed, and understand that through things like threat modeling and going through that exercise. Very important to learn early and often, and reinforce that message that you built. It's much more cost effective to build security into something than it is to retrospectively fix it. Right? I think that's the message of the day here. Right? If you build security in, it's going to be a lot quicker to address issues than it is to fix, and it's like 20 times as much or something like that, right? And probably more actually, but
and a lot more sturdy, a lot more durable.
Yeah, absolutely. Yeah, trying to apply that patch, that kind of where it needs the stitches, I think is quite important. Try to reach security as a habit, and as we always say, always ask questions. There is no such thing as a stupid question. Ask questions all the time. Okay, so. We've got some time.
Yeah, and especially be aware that you also, there are things you don't know, and there are even things you don't even realize you don't know, and that is okay, but that does require frequent interaction to learn about these.
There's the unknown unknowns.
Yes.
And there's the known unknowns, and then there's the unknown. Anyway, the point is that asking questions is always good. Always be inquisitive. I talk about this a lot. If you ask lots of questions, it doesn't matter, it's really important, and actually always be learning. There's always an interesting topic, this, and there's always so many different dimensions to it. So we'll definitely talk more about this in a second. But
speaking of questions.
Well, exactly. I think that tied in quite nicely, don't you? That was quite nice. So I guess really before we wrap this up, we've obviously got some questions, I'm sure. But thank you very much for everyone who's attended us for 90 minutes, or almost 90 minutes. And we look forward to answering your questions. And of course, if you haven't asked any questions now is your time. So we have got some time set aside for this. So did you want to pass the laptop over? Look at this,
yes.
Smooth. Yeah, probably need to use, hopefully my fingerprint works because it's a bit sweaty. Right, okay. Right. Wow. We've got a lot of questions. I don't even know where to start. Right, okay. Okay. I've been asked a question, actually. What exactly is a security capture the flag? That's a really good question. That was asked by Roland. Thank you very much.
So security capture the flag is generally a small application that someone will write where they put a single file with a single randomly generated string in that file, and the file is stored on the same server as that application. And the goal would be to break into the application using vulnerabilities that should be known at that point, or potentially using some of the previously obtained information in order to break into the application and get to the
the flag.
To the file system, basically, in order to retrieve the flag, or potentially get it through, say, directory traversal, or get it through something along the lines of SQL injection from your database. So using vulnerabilities to get to a flag. And the real issue here, or the real benefit here, is that unlike a lot of trainings where every type of vulnerability is dealt with per topic, in Capture the Flags, the attacker, which is generally your developers, or your testing team, or whoever, will not know what vulnerabilities apply to this server. So they not only have to know about vulnerabilities, but also have to know how to find these.
Mm-hmm. Yeah, absolutely. And okay, so there's a couple of ways to look at it as well. There's other examples I can give which are quite quick as well, is that, you know, you could find like the robots.txt file, hidden files on servers. You could be to find a ton of things. So there is, you know, there's a lot of ways of going to capture flags. There's also some great resources out there. Try Hack Me is a pretty good one you can use. There's lots of web application capture flags. A lot of these things are free. There's still Hack the Box, although their web application ones are not as good. They're more sort of box focused, but there are some good ones. There's also vulnerable web application as well. You can just look out for competitions. It's really good and fun to do. Also, we built some of these ourselves as well, and as part of the training, we do this as well. So where it's required. So I've been asked also. Alan has asked. You spoke of a 2-day course. Is that available?
Yes, we do have the course available for sure. We give this training to preferably small groups. We tend to focus on groups up to 15, at most 20 people, and really sit down in a classroom with them for 2 days and go through the OWASP top 10, for example, or the mobile top 10, and really dig into each of the topics, giving them information, giving them background, but also giving them real-life code examples that they can look at to see how these vulnerabilities actually exist in the wild, as we call it. Additionally, we also let them test, at least in the web application version at the moment, we allow them to test on an application themselves in order to see if they can break it, if they can perform these kinds of attacks, and if they can figure out what the fix would be.
Yeah, that's really good. We've got a lot of questions, so we'll go through all of these. We will go through all of these. Okay, there is a question asked, any recommendations for pen test tools?
Tooling is always going to be an aid. So from an actual pen testing perspective, no tool is going to be the human. We would always recommend using things like Burp or Zap Proxy, which are proxy servers that help you pen test by giving you a view of what is actually being sent from your end to the web server. However, no tool really beats manual, thorough pen testing, unfortunately. So. Yep. I can't give you a one solution wonder.
I guess, you know, there are a couple of things you can look at. Obviously, there are some open source tools that will give you a flavour of what's going on. There are commercial tools that will give you a flavour. But as you rightly said, you know, you could look at the Zap Proxy,
yeah.
Which is fairly good. It gives you a fairly good sort of basic understanding of what might be happening, but you can't really replicate the manual ethical hacking because a lot of these things require manual interpretation, understanding the application, context, all those kind of things, right? So yeah, it's a combination of the two. I'm just reading through the other questions. Okay, there's lots of questions here, and there's one very small. Okay, so I've been asked a question about Salesforce, actually. Right? So as we know, Salesforce is a very secure platform, but is there any specific areas we need to concentrate? Any tool suggestions to validate security capability of the application?
So, without going too far into specific pen tests we have done, we have tested multiple applications using Salesforce as a platform. And the most common vulnerabilities we definitely see in Salesforce are authorization issues. So, look for things like functions being accessible to users that should not be accessible to them, or look for things like admin functionality accidentally being available. Additionally, even the most basic things like make sure to set a secure password for your admin account, because the default Salesforce password is not really that secure.
Yeah, absolutely. Right, okay, I've got another big question coming in here. Brilliant. Okay, so I just need to read this because it's a long question. Right, okay, so Philip asks, is the security vulnerability with interceptors like scripts more leaning towards integration with other cloud tools or third-party endpoints? In the example, a microservice architecture on Azure. I guess that's one question.
Do you want to take this one?
Well, yes, okay, I'll ask the second part because there's another bit to this as well. And then there are security that you implement with each application secure code. Then, for example, Azure Cloud Services around security. Okay, fine. I'll answer this question. So, it's like everything. When you're dealing with like ecosystems and microservices, it's trying to understand how those things have been implemented and also the controls that sit around them. So, if you're dealing with like Kubernetes or you're dealing with integration into, I don't know, EKS or dealing with like Docker and things like this. It's about not just the code and the interceptors, it's also about the architecture that sits underneath that needs to be reviewed. So it's more of a configuration issue or misconfiguration issue that causes the most of the issues as opposed to a coding issue, if that makes sense.
Yeah, I would broadly agree with that, is that the more things go to cloud, the more it's configuration based rather than code. Although code that isn't secure on your own server will also won't be secure in the cloud. There's still no difference there. It's just that the focus starts to shift.
Be on configuration at that point. So it's about checking the code, and then it's about checking the interceptors, and it's about checking the configuration of the environment that sits underneath that. I kind of hope that answers your question. That's probably it's a very long topic. It's probably one for quite a long question to answer. So actually, if you wanted to, Philip, did you want to drop an email to us, and we'll probably do that on email because that requires a bit of a longer answer.
Sounds like a plan.
We've got a couple of minutes left, but we've got okay. Okay, this is a good question from Andy. What is the best way to prevent people altering key details in a web form, thus allowing them to update records they shouldn't be able to?
Right. Looking at an application, most forms, what they'll do is they send user data, and realistically, you cannot avoid sending some hidden form fields that send some data about the user back to the backend. The main thing to note is that anything that's sent from a user, even if it's a hidden form field, even if it's a header, even if it's as much as a cookie or a flag somewhere, all of that is by default insecure. So if there is something you actively need to rely on, it should not be sent from the user to the backend in any way. It should always be obtained from the database. Mm-hmm. Does that make sense?
Yeah,
I hope that answered the question.
Yeah, and input validation, sanitization, that sort of stuff as well is probably quite important.
Yeah, that definitely helps with things like the more visible fields, even the invisible ones, of course. I mean, anything that is sent, as I said, is data sent by a user and is therefore untrusted. But nonetheless, it is still potential for an attacker to modify this, because if you look via an intercepting tool, via an intercepting proxy specifically, something like Burp or Zap that we mentioned, it is easy to modify this data even if it is a hidden form field. Yeah. The fact that it's hidden in the interface does not mean that it's hidden in transit.
Yeah, and I guess even if it's a public form, you'd still want to be thinking about whitelisting as well. Expected requests, functions, fields, that kind of stuff as well. So I think hopefully that answers your question. But again, if you want more details, it's something which we can certainly answer over email. And unfortunately, that does mean we have run out of time. And these questions have been fantastic. So we really appreciate it. And thank you ever so much for joining us today. We are doing another one in a month, which is under a month actually. And we'll be talking about supplier risk management. And I'll be joined by Kevin Swatrich and Steve Giacardi to talk to you about that. So again, I'm your host, Stuart Peck. Thank you very much.
I'm Peter Ganzevles. Thank you very much for attending.
And we'll see you again soon. Thank you very much.